This is Daniel Coosbury, and in this lecture, we're going to spend time looking at integers and operations with those integers, and hopefully get ready for some more interesting things with kind of complicated numbers just down the road. But today, we're going to focus on the integer. We're going to start by looking at a few common number sets that are on this page. The first one is the natural numbers, which we usually denote with some sort of fancy looking N, kind of like this. So you might see a bold N in your textbook. And the natural numbers are simply the counting numbers. So it starts with 1, 2, 3, and all the numbers after that are considered natural numbers. So starting with 1, the counting numbers are the natural numbers. So when you see that, that's what we mean. And then we have the whole numbers, which we would denote with some big fancy W. I think it looks like this, or it has a big bold W in your textbooks. And the whole numbers are almost exactly like the natural numbers. They're the counting numbers, but in this case, they start with 0. So the whole numbers are the set of 0, 1, 2, 3, 4, and so on. And so when you see whole numbers, we mean that. And integers are all those numbers, but with integers, we also throw in negative numbers. So integers include the numbers 0, 1, 2, 3, and all those numbers, counting up. But integers also include things like -1 and -2 and so on, and all the negative whole numbers, if you will. So when we talk about integers, basically we mean we're not dealing with decimals and we're not dealing with fractions or anything like that, just the numbers you would count with, including negative numbers. And you might see the set of integers denoted by some fancy Z. I don't know why, but it's a fancy Z, and it'll look like a bold Z in your textbook. So what we're doing in this section is going to include math just involving these kind of whole numbers or negative numbers. We're just not touching fractions or decimals yet. So let's just see kind of a few things we're going to have to do. Here's the number line that has the integers on it. So you see the negatives and the positives and the 0. One of the things we'll have to do in this section is be able to graph numbers, which is not a terribly hard thing to do. If you look at this number line right here, it's already got integers on it. But let's just say we have an example where it tells us to graph these numbers on a number line. Well, we can start by drawing a number line. And when I do this, I like to put 0 in the middle, just because that's where 0 usually goes. And if I wanted to graph number like -4, then I can count back from 0. I know this tick mark would be -1, 2, 3. This would be -4. And I can graph that just by sticking a dot on the number line right there where -4 goes. Same thing goes with 7. If I want to go 7, I'll count up 1, 2, 3, 4, 5, 6, 7. That'll be 7. And the rest of these I can just put on here. So there's 0, there's -1, and there's +1. And maybe we could label these if we needed to. So there's -1. You have to bear with me. I'm working with a really round tip pen, so it's kind of messy. That's how I would graph numbers on a number line. Now, when you start dealing with positives and negative numbers, you're going to have to start thinking a little bit harder about how to order these numbers. You've got numbers like -5 and +5 and -2, and it might get a little confusing where the number should fall. And so one skill we're going to need to get from this section is being able to compare two numbers. So this is asking us to insert a less than or a greater than sign to make the statements true. So for example, here are two numbers, -4 and 2, and all I want to do is I want to say which one's bigger, and we'll put in a less than or greater than sign. So what I've done is I've kind of just included a number line up here, which is easy enough to draw, but I just left one here. And we can see that the -4 is on the left, the 2 is on the right, and the further right you go on the number line, the bigger the numbers get, just in any case. So since 2 is much further right here than -4, we would say that 2 is greater than -4, or we could write -4 is less than 2. So that kind of thing is really clear when you have a number line. If you don't, maybe you'll just have to think of it one way. One kind of rule of thumb is positive numbers are always greater than negative numbers, so that makes it nice. Negative numbers are always less than positive, or in this case, we have 0 and -3. Well, 0 is here. -3 is to the left, so -3 has got to be less than, or we could say 0 is greater than -3. Oh, I did see first B. B is not bad. 3 is bigger than 1. And this last one, we might want to refer up to the number line. The -3 is further left than the negative 2, which means it's smaller, and we would say negative 3 is less than negative 2. So as far as integers go, the larger the negative number gets, actually makes it a smaller number. Down here, we also have signs we'll need to use at some point. We got the less than or equal to sign and the greater than or equal to sign. Those work the same as the less than and greater than signs. The equal to just means the numbers could be equal, or one's less than the other. So 2 is less than or equal to 9 because 2 is less than 9, or 9 is less than or equal to 9 because, well, they're actually equal. So either or, that works, and you got the same for greater than. When we have positive and negative numbers, we can talk about absolute value. Absolute value is defined as the distance of a number from 0. So if you look at the number line here, you can think, oh, well, here's 2. 2 is exactly 2 units from 0, so its absolute value would be 2. In the same way, you can look, oh, look, here's negative 2. Negative 2 is also exactly 2 units from 0, so its absolute value would also be 2. So we're talking about distance here, and since we're talking about distance, then the absolute value of a number always comes out positive or 0, because we always talk about distance as being something positive. For example, here we have the absolute value of negative 4. If I looked up here on the number line, negative 4 is exactly 4 units from 0. 1, 2, 3, 4. That absolute value is just 4. That's the distance from 0. The absolute value of 2, we said that is 2. And the absolute value of 0, well, 0 is 0 units from 0. So the absolute value of 0 is 0. It's not very surprising. Another way to think about absolute value is it just takes whatever integer or whatever number you throw in it, and it spits out the positive version of that. So the absolute value of negative 4 is positive 4. Absolute value of positive 2 is positive 2. It always ends up being positive. Now you might see some different things, like in example 4, where you have some negative signs outside of the absolute value, in which case we got to think of this a little bit differently. So in letter A here, we'll want to think of the absolute value of 2 is 2, just like over here. And then this is saying, well, let's make that negative. So you take the absolute value first, and it makes it 2, and then we'll make it negative. This expression actually is negative 2, since this negative sign comes on the outside. Here we have a negative and then an absolute value and then a negative 5. So we'll want to take the absolute value of this first. The absolute value of negative 5, let's see, it's 5 units from 0. So this is just 5. But then there's a negative sign out here. So we're going to want to make that negative, just like we did up here. This ends up being negative 5. So it gets a little tricky because now they're throwing negative signs outside the absolute value. And then in C, the absolute value of negative 1 is just 1. It just spits out the positive. So what you got to watch out for is these little pesky negative signs outside the absolute value stick, whereas the negative signs inside the absolute value, they end up going away. Everything inside becomes positive. All right, so now that we've done that, we can talk about adding, subtracting integers. We'll do some multiplication in a minute. Adding integers isn't too bad. We've done that our whole lives. So for example, if we have 2 positive integers, we'll just add that like we normally do. And if you want, you can just think of it as 25 plus 14. Do it the old-fashioned way. We end up with 39. But then when you throw in negative numbers, adding gets a little weirder. And so the rule of thumb on this page is if you have 2 numbers that you're adding and they have the same sign, then go ahead and add the absolute value of the 2 numbers, and then you can throw in that sign at the end. So we kind of did that here. These are 2 positive numbers. We added them, and we got 39. And then the sign of that should be the sign of these numbers, which is they're each positive, so that's positive. We can do the same thing here. We're adding 2 negative numbers. So this says, why don't you just add the absolute values of those numbers, so 24 plus 10, and then throw in that sign at the end. So we can do 24 plus 10, which will give us 34. But since these are both negative numbers, we'll have to make that a negative 34. So negative 24 plus negative 10 ends up being negative 34. So that's kind of how that works. If they're different signs, it gets a little tricky, and this is one way to think about what to do. If you're adding numbers with different signs, you can think about it as subtracting the absolute values, and then you want to include the sign from the number with the greatest absolute value. So we'll do a couple of those just so that sentence makes sense. Okay, so here we're adding two numbers with different signs. So this says let's subtract the absolute value, so we can do 21 minus 11, which gives us 10. So just subtract the absolute values. And then include the sign of the number with the greatest absolute value. In this case, the negative 21 has a larger absolute value, so we'll make this negative. So we do the subtraction, and then we throw in the sign of whichever number has the highest absolute value. In this case, 21 is bigger than 11, so we'll do that. Okay, we can do the same thing here. We're doing 34 plus negative 12. The signs are different, so we'll do subtraction. 34 minus 12 gives us 22. And then we'll throw in the sign of whichever number has the larger absolute value. In this case, 34 is bigger in absolute value than negative 12. So we'll make that positive. We can just kind of write it like that. We'll also have to encounter subtracting integers. And so the kind of rule of thumb here that you might find helpful is when we subtract integers, we're going to change the sign of the second number, and then we're just going to add the two numbers. Okay, so in this case, we got 23 and it's minus negative 12. So we can think of this, I'm just going to rewrite it so I can make it bigger for me. This tells us to go ahead and change the sign of the second number. So the second number is negative. I'm going to make that positive. And then we're going to add those numbers, which means instead of the subtraction, I'm actually going to do addition here too. So this problem, 23 minus negative 12, is actually 23 plus 12. Those will give us the same answer. So we add those two numbers together, we end up with 35. So that's kind of that way of thinking about it. It's sort of a trick, if you will. So I can think of that again. I'm going to rewrite this to make it a little bit bigger. If I have negative 10 minus negative 35, and I change the sign of the second number, and then I add the second number. So now I'm adding a negative number and a positive number. So if I go back and think what that last page said, if I add numbers with different signs, I'm really doing subtraction. So I'm really doing 35 minus 10, give me 25. And then I'll include the sign of the number with the largest absolute value, which is the positive sign, since this 35 is bigger. So this ends up being 35 minus 10, which is 25. Okay, let's do that one more time. So if I have negative 14 minus 26, well, here I want to change the sign of this number. So let's make this a negative 26. And then I'm going to add that number. So I'm changing the sign of the second number and then adding. I have negative 14 plus negative 26. Well, now I have two numbers of the same sign that I'm adding together, which means I can add those numbers, end up with 40, and then I'll include the sign that they have in common. So I'll include this negative sign. So that's kind of how I would do those subtraction problems. So these rules of thumb can be really helpful. If you are comfortable adding integers and you don't want to think about it like that, then don't worry about it. But this pretty much kind of sets you up to do similar things in every single problem, which could be helpful. So by now you might be thinking, well, adding and subtracting, isn't a terribly hard thing to do. The challenging thing with this stuff is keeping track of positive signs, negative signs, and thinking about what's going on so that adding and subtracting go well. In the next lecture, we're going to look at multiplying and dividing and do some stuff with order of operations, and that pesky negative sign is really going to come into play more there. So we need to practice adding and subtracting integers, positive and negative numbers, just so that negative sign doesn't mess us up.